prepare for city-level buildings energy benchmark data. Thank you.
Good afternoon, everyone. Good afternoon, everyone. I'm Jen Dai from School of Engineering and Applied Sciences at Harvard, and this is William from Department of Biomedical Informatics at Harvard Medical School. Today, we'll try to answer the question, does LEED result in energy savings using a data-driven analysis? So the motivation of our study is as follows. Buildings represent about 40% of primary energy use and greenhouse gas emissions in the US. And many policies that regulate greenhouse gas emissions in the US use leadership in energy and environmental design, or LEED standards, as a guideline to drive down greenhouse gas emissions. For example, here in Boston zoning code, there's an Article 37 that requires large commercial buildings to be LEED certifiable before they can obtain a building permit for construction. Whereas in California's 2016 Green Building Code, they require large commercial buildings to obtain LEED Gold certification levels. At the same time, there's an increasing focus on municipal data collections that could actually enable evaluating of building standards. So in these studies, we are going to try to answer the question of whether LEED certification really lead to building energy consumption reduction. So first of all, what is LEED and why is it important? LEED is short for Leadership in Energy and Environmental Design. It is developed by U.S. Green Building Council, which is a nonprofit and third-party organization in the U.S. It includes a set of standards for green buildings. It includes standards for energy savings, water efficiency, carbon dioxide emission, indoor environmental quality, resource usage, and some others. It applies to different kinds of buildings, including commercial, residential, and other types of buildings, and includes different kinds of certification for different stages of construction, for example, for new constructions or for existing building renovations. It has 4 levels of certification, so a building could either be certified as certified, silver, gold, or platinum certification. And after you get certified, you get one of those plaques. And these plaques are actually quite prevalent if you look around, and especially around Cambridge and Boston. For example, here's a LEED certification symbol for the Google building in the Kendall Square. Cities have been enacting building energy reporting ordinances, and this kind of provide us with the opportunity to evaluate the effectiveness of the LEED standards. So what are these building energy reporting ordinances? These are city-level ordinances that require buildings to voluntarily report their energy uses, and after the buildings report their energy uses, the system would use EPA's Energy Star system to calculate energy efficiency measures such as greenhouse gas emissions or energy use intensities. For example, Seattle has a building energy benchmarking and reporting program that requires non-residential and multifamily buildings greater than 20,000 square feet to report their energy uses. Washington, D.C. has a Clean and Affordable Energy Act of 2008, which requires private buildings greater than 50,000 square feet to report their energy. And Chicago has Chicago Building Energy Use Benchmarking Ordinances to require building municipal and commercial residential buildings greater than 50,000 square feet to report their energy uses. The city-level building energy ordinances has a variety of information. So they have building identifying information such as the address. They also have information such as floor area and building use type, and so on. On top of that, crucial to our study, they include, in general, 3 measures of energy efficiency. One of them is site EUI, which is the amount of energy that the building uses based on the utility bill. And it also includes an efficiency measure called the source EUI, which traces the heat and electricity usage of buildings back to their sources. To illustrate the difference between the site and source energy, we can look at this plot. So for the site energy, these are just what the building energy meter kind of report, but they don't account for all the energy use that would be required from the source. And the source energy use measurement would kind of account for both the transportation losses and the transmission losses during this process, as well as the power generation efficiency. In addition to those 2 measures, there's also greenhouse gas emission reports. And there's a little bit of a difference between the source EUI and the greenhouse gas emission measurement. For the source EUI, all buildings in the US use the same conversion factor for electricity, natural gas, and steam across the US, so that they could provide a leveled playground for buildings at different regions to measure their energy use. But for greenhouse gas emissions, because different regions have different carbon intensity, there's a different conversion factor for the electricity use to carbon emission. To process our data, we first started with the raw data from the municipal database and the LEED data. We cleaned the data using some basic cleaning techniques to remove the erroneous data. Afterwards, in order to match the 2 databases, we converted the building addresses to latitudinal and longitudinal coordinates in Google Map API and matched the 2 databases. And in order to consider the the effectiveness of LEED in measuring building energy efficiencies, we also have to match these buildings to buildings that's similar to them. To do that, we find buildings in the energy use database that is in the same zip code and have the same building use type as the LEED buildings. After that, we did nearest neighbor matching based on the square footage and the age of the buildings. So here is a result based on the comparison between LEED and non-LEED buildings. So we found that LEED actually does not have a consistent treatment effect for any metric that we provided for energy efficiency. So here are paired t-test statistics with p-values after Bonferroni corrections. Out of the 10 cities that we tested, it's only Washington, D.C. that has a significant difference in terms of energy efficiencies for LEED and non-LEED buildings. In all other cities, we didn't find any statistically significant difference between the energy efficiency between LEED and non-LEED buildings for any of the efficiency measures that we used.
And so here it's also important to note that we chose to keep cities separate at this and all of our future analysis stages because there's a different number of buildings per city, as well as different inclusion criteria for each of the unique reporting ordinances that each of these cities have. So we didn't observe a binary treatment effect in terms of energy efficiency for LEED buildings compared to non-LEED buildings, but we were curious to evaluate whether among buildings who were LEED certified, was there a dose-response effect between the number of LEED credits obtained and our measured observed efficiency. And so we have 3 scatter plots here. The x-axis in all is the fraction of LEED credits obtained by a given building, while the y-axis is our source EUI, site EUI, and greenhouse gas emissions. And in all cases, we didn't observe any statistically significant correlations. This isn't entirely surprising because within the LEED subcrediting scheme, there are multiple different categories, not all of which directly relate to energy efficiency, such as materials and resources or indoor environmental quality. So to address this, we also looked at the associations between fraction of energy and atmosphere LEED credits and our different energy efficiency metrics. And similar to earlier, in none of these cases do we observe any dose-response association. So essentially, the more energy and atmosphere credits you acquire does not necessarily mean that you consume less energy or emit less greenhouse gases. So even if LEED as written isn't necessarily effective at addressing energy efficiency in buildings, the people who are constructing or renovating buildings don't necessarily know this at the time. So we were interested in evaluating the compliance within the spirit of these regulations by looking for distinct subpopulations of buildings in terms of subcredit acquisition patterns. However, our data set consisted of buildings across many different LEED standards, which all contained different named subcredits with different descriptions. So it'd be difficult to directly compare them. There are a couple of handcrafted mappings between one LEED standard to another, but nothing that was on the scale that was required for this analysis. So this is where we decided to utilize natural language processing techniques. So each subcredit had a textual description attached to it. And we utilized a method called term frequency inverse document frequency, or TF-IDF, to essentially treat each subcredit as a function of the component words in its description, as well as the frequency of these terms across all the subcredit descriptions, which would allow us to compute a inter-subcredit distance. So intuitively, we can visualize or think of these clusters of subcredits as sets of credits that share similar words and use them in similar frequencies. And we hypothesized that these clusters would be motivated by similar features from a policy point of view. So on the left here, we have a plot of all the energy and atmosphere subcredits across all the standards that we investigated. And they're colored by the words that were most representative of the subcluster that they happen to be in. So for example, the 5 clusters that we sort of identified here were credits based on refrigeration and refrigerants, measuring and verifying energy use, commissioning and review, renewable energy use, and optimizing energy performance. While on the right, we have 3 examples of pairs of credits that are across different standards and found to be similarly motivated. So for example, we found that the Optimize Energy Performance subcredit from the LEED New Construction 2.2 was similarly motivated to the Minimum Energy Performance subcredit from the LEED New Construction 2009 standard. Or alternatively, the CFC reduction in HVAC subcredit was similarly motivated as the Fundamental Refrigerant Management subcredit from LEED Existing Buildings 2009. So now that we can compare buildings effectively across different standards, we can define the features that we'll use to identify building subpopulations. So we utilize these different features as well as a method called Uniform Manifold Approximation and Projection, or UMAP, which is a nonlinear clustering method that optimizes for preserving local structure. So we've essentially conducted this clustering method over all the buildings in our data set, and we've defined these clusters here on this plot on the left, while on the right we've colored the buildings by what LEED certification level they achieved. And we find that these subclusters are consistent across cities and are only partially driven by the type of construction that was used. And there's 2 main takeaways here. So the first is the fact that we see subpopulations at all is hugely important because it means that the regulatory framework that surrounds LEED is mostly effective. So people are evaluating their construction or building through the lens of LEED and selecting sensible profiles of subcredits for their building. And this implies that changing the regulatory structure around LEED or the subcredit definitions to something that has a stronger connection to energy efficiency or carbon emissions could be an effective strategy going forward. If, as a contrast, we found that people were selecting LEED credits mostly at random, it would be much more difficult to identify a LEED-based policy that could meaningfully change behavior. And second, if we analyze these subclusters in detail, we can get insight into the compliance patterns of these building owners. So for example, among the building clusters that had the highest adherence and highest credit acquisition, half of them were overrepresented among, or oversubscribed to renewable energy related credits, while the other half were oversubscribed to refrigerant related credits. So in conclusion, we find that LEED certification and credit achievement and energy and atmosphere subcredit achievement does not really seem to be an effective at reducing energy consumption or reducing greenhouse gas emissions. But that these subcredit definitions seem to be a meaningful motivating factor on the part of building owners and construction. We find that the similarities across these LEED standards could provide the basis for a more effective, consistent, or precise regulatory scheme for specific energy-related policy, and essentially that there's a need for data-driven regulation in this space, and that the alignment between the types of features that are measured through current regulatory ordinances and the types of targets that we find effective are not currently aligned. Thank you.
So I was wondering if, for the same sort of, I guess, progressions you're running in the beginning to look at energy consumption and GHG emissions, if you did that on all the subpopulations you found, and then in particular, it'd be interesting to know if the sort of subpopulations you found that were sort of for similar credits, if one was sort of beating another, to understand if, then you could pick one over the other maybe.
Right, yeah. That's definitely something we want to investigate further. With the data sets we have, though, as we sort of subdivide the population more and more, it becomes more difficult to sort of achieve statistical significance, both because you have fewer samples in each population and because you're doing more experiments. So any sort of false positive correction you apply makes it more difficult to achieve significance. But yeah, that's definitely sort of the direction we think would be useful to go forward in.
I had experience in helping to plan one LEED building, and it seemed like the game was to get as many LEED points as possible for as little money as possible. Like, what's the cost of a point was literally a metric that we were looking at in planning this building. And I wonder if that's an unobserved variable, though. Is that something that you just can't know?
So we haven't done all of the tests for all the buildings, but we did look at the Boston credits kind of carefully, and I think we did find that buildings tend to avoid the more expensive credits. For example, buildings can achieve credit by having a back rack for transportation, or they could achieve credits for improving their renewable standards, and it's definitely much more common for buildings to have the back rack credit than, yeah. So that's a good point.
And to add to that, like Jen mentioned, we did some Boston-specific analyses. One sort of interesting thing we found was that the MBTA, like in particular, like Boston's strong public transportation network, was essentially subsidizing a lot of credits for a lot of buildings because LEED provides an allowance for credits relating to alternative transportation. And so by getting these credits for free, there's less incentive to seek out more expensive, like renewable energy related credits.
Yeah, thank you. Very interesting finding and quantifying the situation, because we have found that if people go for only points before the building is built, and very few after the fact measurement to validate whether everything has been found. So for example, they have probably sent credit for putting a bike rack, then putting a solar panels, and if the panel is in the shaded area of the roof, doesn't matter. So have you found any other studies which found your type of conclusion?
So there have not been that many studies based on empirical measurements for LEED on a large scale. There are many studies for like single buildings, and the few studies that have been published, I think there's one for buildings in New York City and one for Chicago, and they found similar things to our study. There is one study for California, I think Los Angeles buildings, recently published in Nature Climate Change, Nature Energy, and they did find that by opting in, actually they found that LEED standards have at a statistically significant value with P equals 0.06. So now typically considered statistically significant, but they said there might be some treatment effect.
Okay, so, you know, this is it's a bit of a challenge sometimes with these standards, particularly when they're broadly developed, because you have, you know, it's often not in the interest of developers to develop really innovative solutions. So you talk here for the need for data-driven regulation. Of course, performance management would be the best way to do it, right? You make a target and you meet it, or you lose the standard, right? But what is, like, you know, that's one way to do it. It might be, you know, challenging to convince people that that's the right way. If you had the chance to change lead standards tomorrow, as the, you know, after having done this study, what would you suggest that we do, given this tension and challenge that they would have in enforcing this?
So I think primarily a lot of the tension that comes between LEED and energy efficiency is that fundamentally LEED was not intended for this purpose. Like, it was sort of broadly intended as like a general green building initiative, and I think it's done like a very good job at that. I think a lot of it has just been a mismatch between expectations, where regulators are sort of latching onto LEED as like a convenient tool to use when sort of enforcing like energy efficiency or greenhouse gas emissions, when it's not necessarily the best tool for that. And something we found, at least for like Boston buildings in particular, is that Energy Star score ended up being a much more effective measurement and sort of tool for this particular task. So for instance, like putting a sliding cap on a particular building's Energy Star score ends up tracking much more closely with greenhouse gas emissions and EUIs.
Yeah, so I guess just to add to that, for example, Boston, on top of requiring new construction buildings to require LEED certifiable standards, asked buildings to do kind of evaluation every few years and also improving their Energy Star score a few years, and that probably will have more impact than just requiring them to be LEED certifiable.
Thank you very much.
Thanks.